competitor, like for example, inhibitor, okay, if inhibitor enters the site, let's see, if you see here, this inhibitor has already entered into the site, but this inhibitor has basically spoiled the conformation of the active site. Okay, this inhibitor was a structural analog of the substrate. Okay, and that is why it, it went into the active site. Okay, so but what happened when the inhibitor tried to enter into the active site, it changed the 3D structure of this enzyme. Now there's no place for substrate to enter into the active site of the enzyme. Okay, so one thing you have to remember about this is, usually, I said usually, not always, this is reversible. Competitive inhibition is usually reversible. What do you mean by reversible? Reversible is if you increase the substrate concentration here, you keep on increasing, substrate concentration. It has been observed that if you increase the substrate concentration, okay, if you add excess substrate, okay, the inhibition is what? Inhibited. I mean, it's stopped. There'll be no inhibition. Okay, because the more the substrate you increase, the affinity of an enzyme towards its, darling substrate is going to what? It's going to increase. That is what we have seen. So that is why I said that competitive inhibition is usually reversible. That means you simply need to increase the concentration of substrate, and the enzyme is going to favor the substrate as compared to the inhibitor. Is it clear? Is it clear? You can say the inhibitor is displaced if you increase the concentration of the substrate. Are we okay? Sometimes the question says that in competitive inhibition, do we have substrate and inhibitor? What is the resemblance between the two? You have to say that the inhibitor and substrate are structurally similar. That is why it entered into the active site. Isn't it? The substrate and the inhibitor are structurally similar. Then comes your non-competitive inhibition. This is, you have to remember for always. This is like most of the times, or usually, it is irreversible. Increasing the substrate concentration is not going to help here. Okay. So here what's going to happen here, and this is a very important point to remember, inhibitor here, does it bind to the active site? No ways. No ways. That's where the word non-competitive. Your inhibitor is never going to bind to the active site of the enzyme. It's going to bind to the what? To some other site. Okay, not the active site, but okay. But the problem is the moment inhibitor binds to the, no, look at this. Before binding to the inhibitor, the shape was like this. But after the inhibitor was bound to the different site, okay, not the active site, remember this, okay, then what happened? Then the, no, as soon as the inhibitor was bound to it, then the conformation of this active site was changed. As it was changed, now halas, no catalysis will take place. So remember what happens here. Okay, so no catalysis will, will happen here. So enzyme is of no use to us now. Is it clear? So point number one, you have to remember here, in non-competitive inhibition, the inhibitor does not bind to the active site, it binds to the different site on the enzyme. Okay, it does not bind to the substrate binding site here. Very, very important point to remember here. Okay, and number 2 point, do we have inhibitors and substrates similar structural, are they structurally similar? Of course not. They are not structurally similar. Of course not. They're not. Isn't it? Okay. So that is why even if you increase the substrate concentration, right, it is not going to reverse it. That is why I said that this one is reversible, because there's no similarity between inhibitor and the substrate. So that is why it's not going to increase. So it's not going to be reversed. While as the earlier one, the competitive one, it was the reversible, because there the substrate and the inhibitor were similar in shape. Is it clear to everyone? So then the graph, okay, you can just see this is the competitive one. Look at this. Here, what happened? Initially, we had a graph which was kind of, this was like when we had no inhibitor, the graph was, increased. It's increasing. But here, if you see here, because of the competitive inhibitor, right? We initially had, less response, but the moment we increased the substrate concentration, it came very close to the one which is wherein we never use the inhibitor, like the original reaction. But here, because there's no chance, even if you increase if you increase the substrate concentration, nothing is going to happen over here. Okay. Then this is the same thing. Read the differences, right? Remember this. Read the difference. Very important. Okay. And then there are just few examples. You can just read them. You can just read them. Okay. Gada says, I didn't get the part. Okay. Reversible, Gada. I said that this one is reversible. Why? Let me erase this all. I said that this one is reversible because here they are competing, their structure is similar. Okay, they both are competing for the same site, because here the substrate as well as the inhibitor binds to the same active site, right? So that means, if you remember, I told you the moment you increase substrate, then enzyme is going to favor substrate. Oh, I want you, I don't want inhibitor, because they're competing, right? So the moment you have, for example, you might have 100 molecules of substrate and now you will have 2 molecules of inhibitor. So obviously the enzyme is going to favor substrate, isn't it? Not the inhibitor, correct? No. Did you understand, Gada? But here, if you see here, there's no competition at all. They're not competing for anything. Okay, so inhibitor is binding to some other place, and substrate has its own active site, right? So even if you make them 100,000 substrate molecules, it's not going to help, right? Because here we already have the conformation spoiled. The conformation was spoiled by the inhibitor here, so nothing will happen over here. Okay, if you see here, the conformation was not spoiled by the inhibitor, right? The conformation is still intact, but here the conformation was spoiled. So no matter what, how much ever, if something is broken, you can't mend it, right? You cannot mend it. Yes, Noora, you can leave. As I said that, please do not sacrifice your classes. I should not get tomorrow any, nobody should tell me that you were having the, the revision classes, or you were teaching and they sacrificed, you cannot give this excuse to any instructor that I had a revision class, so please give me attendance for this. So please, if you're going to do that, then I'm not going to have a revision class next time, dear. Please leave it and listen to the recording in the evening. Don't worry. Okay? I'm already recording the session. Don't worry, dear. Please don't sacrifice your English classes or any other class. Okay, dear, because that will be a problem for me for tomorrow. Yeah, even if you have another class, don't worry. Please leave. No problem. Don't worry, because I know you have, because we might take another maybe half an hour. I'm assuming. Okay, within half an hour, maybe we'll finish. I'm assuming that. Even if people who want to leave, they can leave. It's okay. I'm recording the session. That's perfectly okay. Mhm. So thank you. And please listen to the recording in the evening and get back to me if you have questions. So memorize these definitions as well, the differences between the two. And then we have certain, definitions here, and I'm sure that you will just read it. Just give a good amount of reading to these. It's the same thing, between, so just read it, Okay, now this is important. Okay, so can you read by yourself? Can you read all this by yourself? Is it everything, or you want me to explain this? Yes, guys and girls, are we okay? You can, right? Yes, this all this is easy. Okay, don't worry. Okay, great. So let's move on to this. Okay, herein we'll talk about the catalytic power of the enzyme. What is the catalytic power? Okay, if you remember when we started, our discussion, we said that enzymes speed up the chemical reaction by lowering the activation energy, right? That's what we said when I was defining the enzymes, right? They speed up the reaction by lowering the activation energy. Okay, so they do not alter the overall change. If you remember, I told you that if the reaction is exothermic or endothermic, they will not make the exothermic reaction as an endothermic or endothermic as exothermic. No, they will not do that. They will simply lower the energy activation. What does that mean? What is the energy activation? See, for example, if I have A plus B, which is going to produce a product C plus D, let's say. So what is happening? Okay. So what is an activation energy? First of all, let's define the activation energy. What is an activation energy? Energy needed to energy needed to initiate the reaction. If I need to convert this A plus B into C plus D, I need to give some energy, right? So activation energy is the energy which is required by this A plus B to convert all the molecules of A plus B, right, to go into the transition stage. What is a transition stage? Transition stage is a stage here where you never know. Some bonds are breaking, some bonds are making, new bonds will be formed, old bonds are breaking. So all those things will happen here in the transition state. Then only I will get C plus D. Okay, so I gave some energy to this. So they need some energy. They need that energy is the activation energy to form product C plus D. But in between, they will go through a transition state where some bonds are breaking, some bonds are forming new so that the product can be formed. Okay, now you will tell me what is the role of enzymes here? What will enzymes do? Enzymes will definitely, as I told you, if you remember, I gave you an example. If you're traveling from your home to Al Faisal University, you're going by walking, you will definitely reach. A plus B will definitely form C plus D, even whether irrespective whether the enzyme is there or not. But what is your enzyme going to do? What is the role of the enzyme? Enzyme will provide a pathway. Okay, it will lower this activation energy. It will lower this absolutely. If you see here, this was the activation energy which was required to convert, or you can say this one. This was the activation. Where is my pen? What's wrong with it? Okay. This was the activation energy which was required to create my A plus B into C plus D. But what did the enzyme do? If I use the enzyme here E, so it made my job easier. So within no time, the reactants were converted into the products. You chose to travel by car, so you reached to the university within just 5 minutes. That's what happened. Absolutely, Gada. Right? It's something like this. So this is the activation energy, this hill, okay, and these are the reactants. Okay, if they without the enzyme they need to pass this big hill. Okay, for example, if lactose has to be converted into glucose and galactose, but when I use the enzyme lactase, look at my activation energy. Oh, it becomes so easy for lactose to get converted into glucose and galactose in presence of the enzyme lactase. So that's what we say. It speeds up the reaction. It reduces the activation energy. Okay, enzymes can reduce the activation energy by the used by the reactants. Okay, so that was all. So this is the same thing. This is the without enzyme. Okay, and this is with enzyme. Easier pathway. Then the same thing. Then the same thing. We can say that enzymes lower the activation energy for reaction, making transition state more favorable. Okay, And then in this slide, you don't have to prepare this slide. Nobody's going to ask you about the nucleophilic attacks. No. Okay. But yes, you need to know that, if you remember, I told you whenever we use an enzyme, that enzyme has some special amino acids, and those amino acids have some special side chains which are going to favor the enzyme substrate reaction. Okay, and you have to memorize these 5 amino acids which are usually found at the active site of the enzyme. Okay, so which are the amino acids which are present in the active site of the enzyme? They are these 5 amino. Just remember the names, that is it. Okay, so for this one you will just remember the names of these amino acids. Would that be okay? Clear? Okay, moving on further. So no need to memorize the nucleophilic attack and all, no need to memorize it. Then we'll talk about the enzyme regulation. Okay. In enzyme regulation, this is again like if you remember, we spoke about this feedback control in the hormones as well. If you remember when we were discussing how releasing hormones were produced by the hypothalamus, they further activated they further activated the which gland? Pituitary gland, right? Anterior pituitary gland. Then they produced the hormone, and that hormone further activated the thyroid gland. Then the thyroid gland, the TSH was produced by the pituitary gland. TSH further activated the thyroid gland. It produces the thyroxine. So once we have the good amount of thyroxine in the blood, right? So the hormone, the releasing hormone will be inhibited. Remember that? I made a similar kind of graph in, yeah, yes, absolutely. So same thing here again. Okay, so A is converted into B, B into C, C into final product, which is D. So D is my final product. Okay, so D is my end product. So the moment I have a lot of end product, which is catalyzed by enzyme E1, E2, E3, okay, the moment I have my end product, like a lot of end product, kathir amount of end product, right? So it's going to block which enzyme? This enzyme E1. Okay, it will call this is called as a feedback inhibition, or this is sometimes called as an end product inhibition. Okay, means the activity of the enzyme is inhibited by what? By a final product. Very important point to note here. So it's the final product, it's the final product, it's the final product which is going to do what? Which is going to inhibit the activity of the enzyme 1. Okay, when we get a huge amount of end product. Is it clear to everyone? Any question about it? Are we okay, everyone? Okay, thank you. And then we have the another type of enzyme regulation, wherein this is something which is very easy, which you already know actually. But yes, you have to know this slide as well, as I said that. So what are proenzymes? Proenzymes or zymogens are basically the inactive form of the enzymes. Okay, that that must be the part of a polypeptide chain, but those should be hydrolyzed or some groups should be removed. Then only these zymogens become the active enzymes. So how do zymogens become active? Zymogens are inactive enzymes, right? Which are produced, okay? But in order to make them active, what do we need to do? We need to, what? What do we need to? We need to use certain proteolytic enzymes, right? Which can remove some part of a polypeptide chain and make them active. That means if this is my zymogen, let's say this is my zymogen, let's say this is my trypsinogen, you know that most of the zymogens are produced in the pancreas. Like, for example, which part of the pancreas produce digestive enzymes, guys and girls? Alpha cell, beta cell, or the acinar tissue? The digestive part of the pancreas. Mm-hmm. Mm-hmm. No, no, no. Remember the SNR tissue? Yes, it was the SNR, not the alpha beta. It was the SNR part. Remember, I told you this, that is the exocrine part of the pancreas, Yes. So the digestive enzymes are always produced in the form of a zymogen, like your trypsinogen, pepsinogen, chymotrypsinogen. So they're all produced by pancreas in the inactive form. And that inactive form is called as a zymogen, right? So once you have this inactive form, what's going to happen? This has to be, something has to be removed from this polypeptide chain, right? Then they can be formed into active enzymes called as the pepsin, okay, or trypsin or chymotrypsin, and they are your active enzymes. Now, my question is, why do we need to do so? Why are these digestive enzymes produced in the inactive form? What could be the reason? They are then activated by, there are certain, our intestinal wall produces certain, enzymes called enterokinases, and those enterokinases activate these zymogens into, into the active enzymes. But why they are produced in the inactive form? What do you think? Nobody? So that it will not digest anything absolutely, because we don't, because they're protein digesting enzymes. For example, we don't want those things to harm our intestines, right? Absolutely, we want them to be produced only when there is food in the intestines. Very good. Can you give me any example of zymogen from chapter 9? If you remember, we discussed that when we were discussing which hormone we were discussing. What which hormone we were discussing? When, if you remember, we had a diagram. Was it ADH? No. Where did we use angiotensinogen and angiotensin? Do you remember when we said do you remember which hormone was that? I'm kind of tired now. Which hormone helps in the absorption of sodium ions? Renin, yes. So yes, aldos aldosterone. Yeah, absolutely. Remember, if you remember when we discussed that, whenever we have low blood pressure, right? We want aldosterone to be released. If you remember that, we said that uh, you know, kidney senses that, oh, there's a low blood pressure. Okay, so then we have a zymogen called an angiotensinogen. Ladies, do you remember? We had angiotensinogen, which is present in the blood. It is converted into angiotensin 1. If you remember, I told you angiotensin 1 in presence of the enzyme called as the renin produced by the kidney. The angiotensin 1 will be converted into another angiotensin 2 in presence of the enzyme called as an ACE, angiotensin converting enzyme. If you remember, and then this angiotensin 1 can cause either vasoconstriction, increasing the blood pressure, or it can stimulate the production of the hormone called as the aldosterone. Isn't it? Yes. So here angiotensinogen is also a zymogen present in our blood in the inactive form. It becomes activated only in presence of the enzyme renin. That is also a very good example of the zymogen. So what is allosterism? What happens here? Allosteric regulation is basically here, okay? We have certain enzymes are the allosteric enzymes, okay? So what are allosteric enzymes? Allosteric enzymes are the enzymes, they have one catalytic site where the substrate can bind, okay? And then they have one catalytic site where the substrate can bind, an active site, but they also have another separate site where a molecule called as a regulator can also bind. Do you understand? Something like a non-competitive inhibition, isn't it? So here I have the substrate binding site. Here I have another molecule called as a regulator which binds here. What's going to happen? So this regulator, as the regulator and the substrate binds, okay, what is going to happen? The binding of this regulatory molecule here, there are two scenarios. When the regulatory molecule binds here, it can either enhance the activity of the enzyme, or it can either inhibit the activity. So two things can happen here. Very important point to note here. When the regulator binds to the site, not the active site, any other site, allosteric site, so this regulator has a capability of doing two things. One, okay, if the regulator binds to the regulatory site, it can either enhance the activity of the enzyme, okay, so we call that as an allosteric activation. Or if the regulator binds to it, but then what happens? Suddenly enzyme stopped working. What's going to happen here then? It has stopped the activity of enzyme, so it has inhibited the activity of enzyme. Did you all understand what I'm trying to say? So very important point to note here. Okay, very important thing to note here. So remember the definitions as well. What is a regulator? What is a regulatory site? So what is a negative modulation? When there will be an inhibition. What is a positive modulation? When the enzyme activity will be stimulated or increased. That's all you need to remember here. Yes, I will repeat once again. I know this one's a little difficult. Okay, so I have an enzyme. Okay, if you see here, I have an enzyme here, Mariam. This enzyme has two sides. It has one active site where the substrate can bind, but it also has a regulatory side. This is a regulatory side, right? So this can be quite near to the active site. Okay, so what is a regulator? Regulator is something which binds to the regulatory site, okay? And then two things can happen in the enzyme. Once I have a substrate over here and a regulator binding here, two things can happen. The regulator which was, which was bound here, it can either activate the enzyme activity, activate the enzyme activity. If it activates, then we call it the positive modulation. Okay, but then if the activity is not activated, or you can say no, it's inhibited. Okay, if the enzyme activity was inhibited so that the enzyme is now non-functional, okay, so then it's called as a negative modulation. Did you understand, Mariam? So you need to know definition. What is allosterism? You need to know what is a regulatory site, what is a regulator, what is negative modulation, what is positive modulation, right? So two things can happen. Either it can increase or it can completely inhibit the enzyme activity. Okay. So this is also a form of a, then this slide this actually omitted. If you see your textbook, okay, your textbook doesn't have all this. I need to remove this from my slides for the next year students. This is not there, okay? Guys, remove all this. This is not there. Okay? If you see your 12th edition textbook, this is not, all this is not there, okay? I need to update my slides. Okay. Then we have the protein modification. No, but if you see the 12th edition textbook, we recommend reading the 12th edition textbook, not the 9th, 10th, and 11th. If you see the 12th edition textbook, this slide is, this thing is not there. Okay, so that's why this is omitted. However, this part is there, okay? Lian, clear? Okay, then the protein modification. This is something which is super duper easy, which you need to know that. Okay, what does this mean? This means sometimes, you know, an enzyme needs to be phosphorylated. Okay, so sometimes phosphorylation makes the enzyme active. Sometimes phosphorylation can make the enzyme inactive. Okay, so here they have given an example of pyruvate kinase. Pyruvate kinase is an active form of an enzyme. Okay, it is inactivated when it's phosphorylated. What does that mean? That means if I add a phosphate group to the phosphate kinase, it becomes what? It becomes inactive. So the idea here to understand here is, you need to know that phosphorylation can either activate a particular enzyme, or it can deactivate a particular enzyme. That is all you need to know here. Isozymes. What are isozymes? Have you ever heard this term before? What are isozymes? Yeah. So what are isozymes? Is there anybody who can explain this? Yes, Mohammed. I'm having my water meanwhile. You can switch on your mic if you want to explain this. This is like an easy thing. Isozyme. Enzyme that catalyzes the same reaction. Okay. Then what do we need to know about isozymes? The structure is not different. They are different, but there's a slight difference in the structure. They're not structurally that different, right? There's a slight change in their structure. Very good. Other than that, yes, Mohammed. Other than that, okay. This is something which is very easy, and I'll tell you what you need to know, in detail here, because I've seen students always, they don't study this table. However, this table is, we had given a lot of questions, couple of questions from this table last year. So I'll tell you what to study in this table. Okay. So first of all, let's try to understand what are isozymes. Isozymes are when you have same enzyme. Okay, but that enzyme is structurally a little bit different than its other forms. That enzyme acts, in its different forms in different tissues of the body. Okay, so that's called as an isoenzyme, right? For example, remember, it's the same enzyme. Okay, and it's catalyzing the same reaction, same enzyme catalyzing the same reaction, but the same enzyme can occur in different forms. Okay, in various tissues of our body. For example, they took an example of a lactate dehydrogenase. Okay, so they said that this enzyme catalyzes the oxidation of lactate into pyruvate. Okay, and they said this is a tetramer. Remember, it's an enzyme which has a quaternary structure. It has 1, 2, 3, 4 polypeptide chains. Okay, so this enzyme can act in different forms. Okay, they say, it's mentioned that they have 5 isoenzymes. The same enzyme can have 5 types of brothers and sisters. Okay, what are those 5 brothers and sisters? It can simply have, all of them will be M, 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 and M, right? So enzyme is a tetramer of either H or M. So if it's all M, 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 all M same, okay, then you will find this enzyme usually in the skeletal muscle, or maybe in the liver. So this form of enzyme, look at this. When you have all M, okay, similar, all the subunits are similar, like all of them are green, 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 M, 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 then you will find it where? In the liver. You can also find this in the skeletal muscle. Okay, but then sometimes you have M, 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 and then you have one H, another subunit H. Okay, we call it M3H. Okay, at that time you can, this is also found in liver. Okay, and M3H is also found in the skeletal muscle. So you can find this one also in skeletal muscle and as well as the liver. Okay, but then you have M2H2, which is usually found, if you have M2 and H2, which is usually found in the brain. Okay, this is it, M2H2. Okay, and then you have MH3. Okay, what is MH3? When you have 3 times H and then just one M. Okay, so you will usually find this one in the heart. This one and this one, you usually find you find it in the heart as well as in the RBCs. Okay, so that is not important. What is important here is, so it has altogether different job to play in different parts of the body. Okay, so then it has something to do with the glycolysis and pyruvate. So let's not discuss all that because you have not, you don't know about the citric acid cycle right now. So let's concentrate on this slide. The definition. What is an isozyme? It's a tetramer. Okay, with H and the M. So you can have it. You can have different combinations. You can have all M together. You can have all H together. You can have M3 and H. You can have H2M2. You can have H3M. Those are the 5 isomers of the lactate dehydrogenase. That's all you need to know. Okay, because this enzyme is so very important in cellular respiration. Once we start cellular respiration, how glucose is converted and gives us energy. So this enzyme is going to be very, very important. Okay, so since you don't know the citric acid cycle, so we'll not talk about all this here now. Okay, yes, now this table, you don't need to know this part, you don't need to know this part, but yes, this thing and this thing you need to know. Sometimes we kind of ask our students, okay, tell me, in heart attack, if a person has an heart attack, what kind of enzymes are will be in increased quantity, okay, in a person, for example, if a person is suffering with a heart attack. So at that time, doing some tests, which it can tell us that if it has a lot of lactate dehydrogenase, then a doctor might, suspect that, he might be having a problem of heart attack. So you just need to know, okay, about all that. So for example, hepatitis, which enzyme is elevated or increased in hepatitis? So you will write it's alanine amino transfer. Just remember this and this. In prostate cancer, it's acid phosphatase. Liver or a bone disease, which enzymes increase in quantity? Alkaline phosphatase. In pancreatic disease, you have the amylase. Okay, so is it clear to everyone what you need to do? Yes, you need to know the elevated enzyme and the disease which is diagnosed. And then even this is not in your new textbook, so this is also, you don't need to know this. Okay, this we are going to delete from the next time. Okay, so enzymes, you can simply read this. Enzymes are the, enzymes, which have, the if you remember, antibody based enzymes. That's all you need to know about it. Okay, so with that we finish the chapter. So now tell me, do you have any question about it? You guys are tired? Oh no, is everyone tired? We started at 9. I actually started at 8. I have been teaching since 8 in the morning. Oh my god, almost for 5.5 hours continuously. Yes. But what is important is, did it help you? Re-explaining both the chapters, did it help you? It was a useful session. Thank you, dear. That is important. That's so very important, right? If it benefited you, that's really important, right? So now it's your turn to study everything, right? To revise everything, so that inshallah, you will come out with good grades. I'm telling to everybody, whether you're Mr. Muhammad students or my students, like, please study thoroughly everything and try to touch everything. Don't try to think this is important, that is important, right? So if you have any doubts, if you feel like, if you have any doubts, you can always send me an email, right? And about the one chapter which I need to teach you, and I mean, that was already taught to you by Mr. Mohammed. I'm going to reteach you that chapter, is the neurotransmitter, and we all decided that we're going to teach you that, on Friday, right? On Friday, and I will let you know whether it will be the afternoon or in the morning, but I'll let you know. Okay?
Doctor,
Yes, dear.
so this is where we're gonna stop. Just this chart.
Okay, I told you that, no, not here. Give me a minute. I'm just looking for my pen. Uh, so this is actually not, as I said, that this is not in your book in the 12th edition. This is not in 12th edition. So this one you need to study. Okay, just study the definition. What are abzymes? That should be okay. Okay,
Okay, thank you.
what are abzymes? Yeah, that should be okay. Okay, antibody based enzymes are called abzymes. That's all you need to know, nothing in detail. Kind reminder to post these revised PPTs. Yes, dear, I will do that right away. I will do that right away. Right after the class, I'll finish that. Okay. And what else? And I hope the recording was not, because as I said that when we have a long classes, it's very difficult to upload a long recording on Moodle. But I will try to find out a way. Okay. And that's all. That's all for today.